Hello boys and girls and everyone who lies between. Thank you for joining me in today's video. As you may notice, I'm very soft spoken at the moment because it is midnight on a Saturday. Because I am a what loser and recording this video for you. So, today's video, we are learning how to change the subject of a formula. Okay? So what is the subject of a formula? So in the equation, x minus 2y minus x equals 2y minus z, x is expressed in terms of a y variable and a z variable, and x is on its own on one side, so therefore x is the subject of this equation. However, if I changed this equation now to z equals 2y minus x, as you see here, I just manipulated the formula in a way where I just got z on its own. Z is now the subject of the formula because it's on its own and is written in terms of the other two variables. So this process of changing, this process is called changing the subject of the formula or rearranging the formula. The process of changing the subject of a formula is very similar to solving equations. I have some basic rules that will help us, but all the general rules from solving equations carry over into this topic. So, what are the rules? The 4 rules I have for rearranging formula. These are your 4 steps. Follow these steps and you should be able to rearrange anything. Okay, first step, identify the variable that you need to isolate. Luckily, in your exam, they will tell you what you need to isolate. They'll say, rearrange this formula in terms of x, blah, 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 blah. You know what I mean? Part 2, rule 2, you need to remove all and any fractions via lowest common denominator, i.e. multiplying every term by the lowest common denominator. That's something we learned 2 videos ago, if it's uploaded by now. Might be. Anyway, step 3. Factorize fully the subject term if needed. You're gonna know what I mean by this shortly, but all I mean is if I have multiple terms that if I have multiple terms that have the variable I need to isolate, I'm probably gonna need to factorize it to get it down to one term with the variable in it. That doesn't make sense, but it will, maybe. Anyway, and finally, step 4. Once the other 3 steps are completed, step 4. This also applies to solving equations as well. Apply BIM-DAS backwards to make the variable the subject of formula. So how when we perform normal arithmetic, we use the order of operations, BIM-DAS or BirdMass or whatever you use, right? As long as that PEMDAS. Ugh, right? Just apply it backwards. So I have BIM-DAS backwards here. You can use the acronym SAMDRIB. Sounds like an ointment, really, to be honest. So just maybe say BIM-DAS backwards. Anyway, so we first off by getting rid of the terms that we're adding and subtracting. Then we're getting rid of anything I'm multiplying and dividing my chosen term by. And then finally, indices and brackets. Again, this will make more sense through an example. You know, there's only so much I can do by just talking to you guys, you know what I mean? Right. So, here we go. Here's an example. Y equals 2x minus 6 all over 3x minus 4. Express x in terms of y, i.e. make x the subject of this formula. Right, step 1. Remove fractions by multiplying each term by the lowest common denominator. So, I need to find the lowest common denominator here. If you remember, anything on its own is always written over 1. Yeah? So my lowest common denominator is just going to be 1 times 3x minus 4, which is just 3x minus 4. That's my lowest common denominator. So now I'm now multiplying each term by 3x minus 4. So I have 3x minus 4 times y equals 3x minus 4 times 2x minus 6. Oops. all over 3x minus 4. These will cancel out. So I'm going to be left with now 3x minus 4 times y is equal to 2x minus 6. And that's me done for the first step. Don't get ahead of yourselves, only the first step. Really hope you can hear me. Anyway. Step 2. Factorize the isolated variable x and expand the bracket. Factorize the isolated variable? Okay, I think I wrote that wrong. I'm only human, I make the mistakes. Anyway, we're just factorizing the variable x. Yeah, we're just factorizing the variable x. Because as you see here, I have two terms now. And both of these terms contain an x. And in order to isolate x, I need just one term with x. Because then it doesn't work, babes. It doesn't work. It doesn't work when I have multiple terms that have x in it. So, first step, multiply out my bracket here. So I have 3y x minus 4y equals 2x minus 6. Perfect. Next step, group my x terms together. So I have 3y x minus 2x is equal to, and I'm just going to bring this over to the right hand side anyway. Yeah, so minus 6 plus 4y. So I'm going to factorize this term now. So I'm going to be using the highest common factor method. Usually with rearranging formula, you will only ever be using highest common factor. I cannot recall it top of my head if you have to use any other form of factorizing, but if you do, I didn't say you didn't, but you never do. Anyway, so I'm going to take out an x. So we have 3y minus 2 in my bracket here is equal to minus 6 plus 4y, or just rewrite that to be nice, 4y minus 6. Right, okay. Next step, apply BIM-DAS backwards. Okay, well, I kind of, okay, I did the first bit here. So I brought over, so I did the AS part. I did the AS part. So I brought over my minus 4y, made that plus, brought it over because I was adding and subtracting that from my x term. So the AS part is done. So the MD part, yeah, the MD part. So am I multiplying x by anything? Yes, in fact I am. I'm multiplying x by 3y minus 2. Perfect. So I'm going to divide both sides by 3y minus 2. So boom, boom. I have x is equal to 4y minus 6 all over 3y minus 2. And that's my final answer, because I don't have any x's on the right hand side, and I've been asked to express x in terms of y, and that's what I did there. So bada boom, bada bing. Right. Next example here. Here's one. Given that p is equal to q or cubed, right, or in terms of p and q. Right, so step 1, I isolate, identify what I need to isolate. I need to isolate or, fab. Step 2, get rid of any fractions. I don't have any fractions, done so. Step 3, factorize or fully. I only have one term that has an or, so therefore don't need to factorize, bada boom, bada bing. Next step, BIM-DAS backwards, right. So am I adding, I'm looking at my initial expression here, am I adding or subtracting anything from the term that has or? No, I'm not. So donezo, first step. Next step, am I multiplying or dividing the or term by anything? I am. I'm multiplying, or the or variable by anything. I'm multiplying it by q. So I need to now divide both sides by q. Right, so I'm just going to get or cubed on its own, and I'm just going to get pq on the left hand side there. So multiply, divide, and done. Fab. Indices. Am I I indices. So indices or powers or whatever you index. Am I putting my or term to any powers? Yes, I am. I'm putting it to a power of 3. So if I have a power of 3, the inverse of a cube is a cubed root. So it's just the same as a square root, but you put a little 3 in there. And then the cubed root of or cubed, well, it's just going to be or. So i.e., what do I multiply by itself 3 times to get or cubed? Well, it's just going to be or. And that's the answer. So the cubed root of p divided by q is equal to or. Right. Here's another example. Given that u squared plus 2as equals v, write a in terms of u, v, and s. Okay, u, v, and s. So I need to get a on its own. So I have a in here. Right. First step, identify. I did. Second step, remove any fractions. I have no fractions, so I'm fine. Step 3, factorize a fully if I can or needed. Don't need to factorize a. Done. Step 3, BIMDAS backwards. Now, this is where it gets a bit tricky. Not really a bit tricky. But now, am I adding or subtracting anything to the term that contains a? So am I adding or subtracting anything to this? No, because this is all trapped under the square root. Yeah, so am I adding or subtracting anything to this? No, I'm not. So I'm going to leave it. Am I multiplying or dividing this square root by anything? No, I'm not. So I'm done. Right now, indices and roots and powers. Now I apply the BIMDAS backwards. So I have a root here, square root. So I need to square both sides. So if I square both sides here, I'm going to get u squared plus 2as is equal to v squared. Right, and now I need to do the process of BIMDAS backwards again. So am I adding or subtracting anything to my a term? The term that has a. Yes, I am. I'm adding a u squared. So I'm going to bring that u squared over, get rid of it, make it a minus. So I have 2as is equal to v squared minus u squared. Second step, am I multiplying or dividing a by anything? Yes, I'm multiplying and dividing it by 2s. I'm multiplying it by 2s. So I need to divide by 2s. Both sides, boom, 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 boom. So I'm now going to have a is equal to v squared minus u squared all over 2s. And that's my answer there. That was a wee bit tricky. Right, so look out for the ones with the square root because they will be coming kind of last because of the I part, or the part in bird mass. So remember, brackets, indices, or roots. So we'll be applying them later when we do it backwards. And then finally, one more example. Here, okay, technical difficulties. Hello, my baby. Hello, my honey. This is so awkward. Please wait a moment. Your patience is really appreciated. Thank you for waiting. Oh my god. Right, okay, here we go. So, make A, sorry about that. Make A the subject of the formula S equals UT plus half AT squared. Right. So make A the subject, so i.e. get A on its own. So I'm not having a look at this, having a look at the initial formula. I'm just going to write it here to make it clear. So S equals UT plus a half AT squared. So first step, get rid of the fractions. My lowest common multiple here, or lowest common denominator, is going to be 2. So I'm going to multiply each term by 2. So I'm going to have 2s equals 2ut plus, and then 2 times a half at squared is going to be at squared. Fab. Right? That's step, well, that was step 1. This is step 2. Step 3, do we need to factorize anything? No. Done. Right, so step 4, bird mass backwards. So, applying bird mass backwards, am I adding or subtracting anything to the term that contains a? Yes, I am. I'm adding this 2ut. So I'm going to bring that over and make it a minus. So I have 2s minus 2ut equals AT squared, right? So that was the ass part. So 2s minus 2ut equals AT squared. Now, am I multiplying or dividing a by anything? Yes, I am. I'm multiplying a by t squared. So I need to divide both sides by t squared. So I'm going to have 2s minus 2ut all over t squared is equal to a. And therefore, I have made a the subject. Now, also remember, this could be flipped around. I could say a equals 2s minus 2ut all over t squared. It doesn't matter that like I have the equals a on the right hand side, because now some people are going to ask that. Anyway, finally part B. Hence, find the value of a. So find the value of a if s equals 40, u equals 10 meters per second, and t is equal to 3 seconds. So, oh, if in case you weren't wondering, if you're wondering, by the way, this is a displacement formula that you learn in applied maths. So if any of you do applied maths, you're going to be very aware of this. But so a in this case is acceleration, but they'll specify that in the question. I'm rambling, right? So I have my a equals, so it's 2 times s equals 40. So 2 times 40 minus 2u, so it'd be 10, t, which is 3, all over t squared, which is 3 squared. So a equals 80 minus 60 all over 9, which is equal to 20 over 9 meters per second squared. And that's my answer for A. And that, ladies and gentlemen, and everyone in between, is how you rearrange a formula. And a few examples of how to do it. Really hope this helped. Hope it helped. If it helped, smash that like button. Let's break my record of 1 like. Anyway, oh my god, 18 minutes. How do I keep doing this? Anyway, my voice is a bit hoarse. So, yeah. Good luck. Bye.